All right, we're taking a look at day 6 today, which is trapezoids in review. So we went through this stuff in class, and I'm just doing a little recap in case you were absent today. So for starters, a trapezoid is a quadrilateral four-sided figure, and it's got two parallel sides, just one pair of sides parallel. Those two sides are called the bases, and then the other two sides, which are non-parallel, are called the legs. Now, I want to bring your attention back to a concept we talked about before, which is if I have two parallel lines cut by a transversal, these two angles that are in the on the left side but inside the parallel lines are called the same side interior angles, and those angles are supplementary. So these two pairs of base angles on the non-parallel sides here, A and D and B and C, are going to be supplementary to each other. They're going to add to 180. Okay, so we'll be able to say that these sets of angles here add to 180. Now, an isosceles trapezoid, on the other hand, has two pairs of sides that are parallel, and the non-parallel sides, which are called the legs, are congruent. So that would be AD and BC here. And these two pairs of base angles, which are at the top, along the base, are going to be congruent to one another. The other thing that they have going for them is they have congruent diagonals. All right, so two things. Number one, when they tell us that they're a trapezoid, 95% of the time when they do that, they're going to be looking for sides or angles. We're just looking for the angles along the same base. If it's an isosceles trapezoid, we're going to be using either the congruent diagonals here, all right, the congruent base angles, or the legs congruent. So those are the things we got to keep in mind as working along here. All right, the other one is that in the trapezoid above, remember that the angles, the base angles are going to be equal. So angle A is going to be congruent here with is a base angle, and that gets paired with angle D, and then angle B and angle C are the ones that are the other pairs of base angles. No, that's not right. Angle A and angle B are along the same base. Those are base angles. And then angle C and angle D. Those angles, AD and BC, are supplementary. Now, there's two angles that are supplementary, like we just talked about 2 seconds ago. All right, are angle A and angle D. And then angle B and angle C. Those are supplementary. All right. Now, if we go and take a look at the first question here, we are trying to find the measure of, or the value of x if possible. Remember that these two angles along the non-parallel side are the sets of angles that are supplementary. So we're going to know that these two angles add to 180. And we're going to create an equation that just says that 5x plus 75 is equal to 180. We can move the 75 over and then divide out by 5 to get x is equal to 21. In the second question, okay, we don't know that this is isosceles. It just says it's a trapezoid. So these two angles, which are along the same base, are not the same side interior. So these will not be supplementary. We don't know how they're related. So this is not possible. Unless it's this isosceles, then we could say that these are equal. But for right now, we don't have enough information. Let's take a look at number 3. All right, in number 3, we have an isosceles trapezoid. We're referring to angles 1 and 2. So hopefully you remember those angles are considered to be base angles there. And we know that those are going to be equal. And so that's going to start our equation. We're going to set 14x plus 5 equal to 17x minus 10. Remember, we want to get all the x's on one side, so we'll move that 14x over. And we can also move all the numbers on the other side, so we'll move the 10 back. And we'll end up with 15 equals 3x. And then we can divide it by 3 and get x equals 5. All right, see if you can pause and try number 4. All right, hopefully you got an answer of 20. So once again, these two angles are same side interior, they're supplementary. So just 7x plus 2x equals 180, and then we'll divide it by the 9 after we combine like terms. All right, and that is going to finish up with this page. Let's take a look at the next one. Okay, so starting off with our median of a trapezoid. So remember, the median is the word for us that means the middle. And what we're talking about is this middle segment, and MN is essentially cuts through the middle of the trapezoid. It has to cut through the middle of the two legs. So the median is going to be the segment that connects through the midpoints of the legs. And oftentimes it'll either say that those points are midpoints, or they'll tell you that these two pieces, AM, MC are equal, BN and D are equal. And then we also know that these lines, AB, MN, and CD have to be parallel. So if we know our segments of mid-segment, we know two things, okay? Number one, the median, or the mid-segment of a trapezoid, is going to be parallel to the bases, and it's going to equal 1/2 the sum of those two bases. All right, so the equation we'll be able to create is that MN is equal to AB plus CD divided by 2. So let's apply that to the first question here. So for starters, we can label those segments on our diagram. And remember that because M and N are midpoints, this line is going to be the mid-segment. So the equation we're going to create is that the mid-segment, okay, the median here, is the average of the two bases. So we're going to add 12 and 18. We're going to divide by 2. And it's going to equal that median slash mid-segment here, which is 2x plus 1. Now, the easiest way in general to solve is to cross multiply. I know you could add and then divide by 2, but sometimes when the x is actually one of the two bases, the easiest way is to start by cross multiplying. So if we double 2x plus 1, we're going to get 2x times 2 and 1 times 2, so 4x plus 2. And then 12 plus 18 is 30. Now we can just move the 2 over and then divide by 4 to get our answer. You could have combined like terms and divided by 2 to get 2x plus 1 equals 15. You get 14 and 7 either way. But in general, I like to just talk to the students about, and anyone following along here, with cross multiplying first and then combining like terms as you do that. All right, let's try number 6 here. Okay, so number 6, remember that we are given our 3 segments. We already knew from the directions on the top that M and N were midpoints, so we know that this is our median or mid-segment in our trapezoid. And what we are going to do is start off by labeling our sides. So remember that the mid-segment, the median, is the average of the two bases. So we're going to do the x plus 7 plus 3x plus 13 divided by 2, the average, right? Add and divide by 2 is equal to 30. So we're going to start off by making this a fraction and then cross multiplying. Okay, now we are doing 2 times 30 and 1 times all this stuff over here, x plus 7 and 3x plus 13. So we're going to do 2 things at once. We're going to cross multiply and we're going to combine like terms. So we're going to get 60 and then we're going to get 4x plus 20. From here, we can move the 20 over to get 4x equals 40, and then we'll eventually get x is equal to 10 when we divide both sides by 4. Now, in these questions, also be careful to check to see if they want just x or do they want one of the lengths. So make sure you double check you're answering the question before you're done. All right, I'll leave you to try number 7 on your own. We'll give you the answer here in a second. All right, and hopefully you got an answer of 3. So remember, we're going to label our figures here. Now, a couple different ways that you could go about doing this question. Remember, we talked about first step, just cross multiply and combine like terms. If you wanted to add like terms and divide by 2, you could also do that. It's up to you. Here we'll get 6x equals 2 times 10x minus 21. So 6x equals 20x minus 42. Bring the 20x back and then divide by negative 14. If you wanted to instead do 6x and divide by 2, you can get 3x. Then you'll kind of get the same idea here, where you'll end up with negative 7x equals negative 21, and then you'll end up with 3 as well. So a couple different options in terms of how to get this. But if this doesn't work out to be something that's divisible by 2 very easily, that's where our cross multiplying is going to come into play. All right. I'd like you to work on just finishing up the next couple pages here on your own, so pages 20 and 21. We did take a look at number 9 in class together. We'll walk through this one real quick. On this question, because this is an isosceles trapezoid, this is the other situation that pops up every once in a while where we have for ourselves a isosceles trapezoid with an altitude drawn in. When that happens, we almost always want to draw this other altitude CF here, okay? So let's just take a look at this piece by piece here. With number 9 here, we're starting with an isosceles trapezoid, and we have AB equal to CD. So we know that these two legs are equal. Now, anytime we see this altitude being drawn in, we almost always want to add another altitude on the other side here. So if we drop another altitude from C, we'll call this point F, we know we're going to end up with our right angles, our congruent legs, and our base angles congruent. So the cool thing about this, or the thing that's important here, is these two triangles are going to be equal to one another. And because they're equal, we are going to end up with a rectangle in the middle and two equal triangles on the outsides. So we'll know if this top line is 12, that this bottom section from E to F is also 12. And the reason we know that these two triangles are congruent is because they have congruent legs, base angles, and right angles with angle side. So we'll know that these two triangles are equal, all right? And that means we can figure out the distance from A to E, and that's the same as F to D. And so if we just take 22, subtract 12, which is on the bottom here, this whole piece was 22, we'll get left with 10, and that each of these has to be 5 in order for that to be true. Now from here, in order to find the length of this altitude, this length BE, which is what we're looking for, we're going to have to use some Pythagorean theorem. So remember that A squared plus B squared equals C squared is kind of the same interpretation of leg squared plus leg squared equals hypotenuse squared, and the hypotenuse is always across from that right angle. So we're going to want to create an equation where 5 squared plus x squared equals 13 squared. Remember, we're going to square those numbers first, get the x squared term by itself, and then square root both sides to get our answer of 12. All right, and then for homework tonight, I would like you to finish up pages 20 and 21 with the review of our quadrilaterals unit. All right, we'll see you guys tomorrow.